Okay, here we are. Hello, everybody. I'm here together with Liam from Cosmonic. Good to have you, Liam. How are you?
It's great to be here. Thank you so much for having me on today, Chris.
Yeah, sure. Pleasure to talk again. As you know, right, at Betty Blocks, we're a big fan of Wasmcloud and Cosmonic as well. Maybe can you give us a quick elevator pitch of Wasmcloud? What is it?
Sure. Wasmcloud is designed to help companies easily onboard and adopt WebAssembly at scale. WebAssembly is a standard that is created by the W3C, so it's completely open, much like HTML. It's already achieved dominance in places like client side communications, but it is increasingly the sandbox of choice for all application deployments. So, big platforms and experiences that are based on WebAssembly include platforms like Cloudflare, Fastly, CNCF Wasmcloud. And Wasmcloud in particular is designed to bring WebAssembly to server side computing. So if you're running Kubernetes or building platforms with VMware or Red Hat OpenStack or any of the cloud or managed distributions of Kubernetes, Wasmcloud is the easy button to let your developers start building with this powerful sandbox. Cosmonic provides an enterprise grade distribution of CNCF Wasm Cloud, and it includes a lot of common turnkey features such as default integrations into the four domains of platform engineering: build, run, observe, and access, and then provides supported tiers for enterprises like banks, folks in the EU concerned about sovereign cloud, governments, military, things like that.
Yeah. And for people who might be a little bit new to this topic, um, it might kill Docker and containers in a way as well, right? For a lot of use cases. Is that a provocative statement, or how
I,
truthful is
I
that?
think I think it's more about building better together. To be honest with you, Chris, I think that the whole history of computing gets dominated by a popular abstraction. Let's go back to maybe when I got into tech, and in the early days of the microcomputer age, every application got its own server, and there was a lot of overhead with that. Every team then had to think about RAID controllers and power management. And we used to make sure we would buy our servers that have two plugs so we could plug them into two UPSs so we had redundant power. And it led to a world where there was a ton of underutilized capacity. So folks said, hey, why don't we start co locating and sharing this layer? How do we share first our CPUs, virtualization, our data centers, public cloud, our operating systems, containers? And you see this linear progression where we're moving up the stack and sharing more and more of the common features, making them templates, things we can provision instantly versus via a long-winded supply chain. And WebAssembly is just a continued abstraction in that linear path. WebAssembly is an abstraction kind of at the application layer, and it enables us to empower developers to just ship business logic and then run on a container in Kubernetes in a public cloud in someone else's data center, turtles all the way down. But it comes down to choosing the right tool for the right job. Let me give some examples. In really like real-time computing scenarios, you'll often specify a specific set of hardware. You won't use any virtualization because the microsecond timing is really sensitive, and you want to use formal methods to sort of prove out these logic paths, and you might be doing some control systems. In other scenarios, you might just want to get a piece of code that just runs occasionally or can scale effortlessly. I think it's about having lots of different choices and choosing the right abstraction, whether it's WebAssembly, containers, a virtual machine, or even a physical PC. They're all valid, and they're sort of trade-offs, pros and cons at each layer.
Yeah, and the last couple of decades, software development and architecture has also been a lot about microservices, right? The services-oriented
Yeah.
architecture. So how does that tie into WebAssembly in one end, and how does Wasm Cloud play a part in that?
Yeah, I mean, I think microservices, uh, you know, there's the obvious benefits of taking complex apps and breaking them into smaller pieces. And when you think about the advantages of these workflow, what you're doing are you're reducing, this tight coupling of an application, and the sort of long end tail of this was really articulated very well by a great engineer, Tom Killeg. He was instrumental in the early days of Amazon. He wrote this article for the ACM called "The Hidden Dividends of Microservices." If you haven't read it, you should absolutely read it. But he talks about the idea of enabling permissionless innovation, enabling failure of a smaller component and thinking about the resiliency of smaller parts of your application. Think about like an S3 outage in one AWS region, but still being available in another. The ability to disrupt trust and improve communication across teams. When you move to things like microservices, the part of the idea is that teams stop meeting with each other. Teams publish their APIs and they have an abstraction for how they interface with each other. So for large orgs, moving to microservices does have a bunch of hidden dividends, but it also tends to have some drawbacks that WebAssembly kind of addresses. If you're what we see when we get brought into say like a US Fortune 100 bank is they will sometimes have say like running your bill or your invoice, could cross hundreds of microservices just to generate your report. And to pivot through all of those layers of containers and abstraction sometimes means that the request can take a long time. And when you look at traces, what you see is there's a lot of TCP handshakes and like moving across distributed infrastructure here, because containers are great and the sort of standard way to deploy microservices, but WebAssembly gives us a smaller way to deploy code. So think of it as just your business logic. But the hidden dividends of WebAssembly let you do things like co-locate more logic in a single sandbox. So when you're enabling these microservice API driven innovations, you can still achieve very fast scale. And it makes it clear why like the sort of new edge and the new platform companies like Cloudflare are building, Cloudflare Workers is largely WebAssembly underneath the hood. They use a different runtime than what we use, but a very similar type of architecture and choice in order to get out there. Was that a sort of helpful perspective, Chris, on how we think about microservices and the hidden dividends of WebAssembly?
Yeah, I think it does, and um, I'm a big fan of the component model as well. Um, and I think is that also tying into this WebAssembly or this microservices problem, the problem that we have seen, right, writing
Yeah,
applications through the years, is that although you have a separation of concerns per services, it's hard to publish a let's say a hardened interface in an easy way. Of course, there's Swagger, Open API, and stuff like that to publish your API, but sometimes that's way too complex if you have a small interface or a
yeah.
small service. And I think the component model, right, and that's also part of the bytecode alliance, which is the same bit as WebAssembly. Does that help as well in your view?
Yeah, absolutely. When we think about WebAssembly, let's start with, what is it? WebAssembly is a bytecode and it's designed to be very easy to consume, very easy to read. And there's two different formats of it. There is, what's called a WAT that lets you almost look at assembly style instructions. And then there is a compiled, binary format that you would use for execution on a system. And when we think about the challenge of just connecting to microservices, let's take like a Go Lang API and a Rust Lang project. You think about if I want these two things to talk to each other, oh, it's easy, right? I put them both in a container. I set up a web server. I serialize it to gRPC. I do a TCP handshake, and then I exchange data, right? 5, 10 milliseconds. It's awesome. What the WebAssembly component model introduces is a common lifting and lowering format so that we can take the data types across language boundaries, say Rust and Go or TypeScript and C++, and we can do the lifting and lowering to meet at a component layer. So what it does is it takes your compiled WebAssembly artifacts and it produces something called a WebAssembly component. And a WebAssembly component works very much like a Lego block. if I have the same interface, or if I have a set of blocks that can meet my interface, a 4 block could have 2 2s or a single 4, then I have the ability to connect these components together. And the standard itself has its own IDL that enables us to do that kind of lifting and lowering. The aim is just to give developers the ability to think about business logic and stop spending time over and over again thinking about composition and connectivity. Those are things that are default concerns, so we want to shift those down into the center of the platform.
And if you look at use cases for WASM Cloud based applications, right? So, what are some interesting use cases that you have seen in the field right now?
Yeah. I mean, Wasmcloud, I think, has attracted. When we think about the default properties that WebAssembly brings to the table, WebAssembly is a really powerful sandbox. It starts with zero computation space, and as I compile in my code, I only give it access to those resources that it needs. So its strong security guarantees, its performance, its ability to run at ultra density has drawn customers from regulated industries first, which may sound like an unusual starting point. But there are a lot of orgs that start with security as a preeminent concern, and or that think about things like portability and survivability as requirements on day one. And having a small sandbox that is ultra secure, that is very dense, and can be operated inexpensively across redundant infrastructure means that a lot of the orgs that need to be on all the time, telcos, governments, military, financial services, have really gravitated to WebAssembly. And increasingly, we do see small startups building with WebAssembly because they understand the advantages to get out there. When you look at it from a project perspective, what we really tried to do with CNCF Wasmcloud is to bring WebAssembly to where enterprise teams are already. Enterprise teams tend to be the first ones to understand the organizational need for WebAssembly, the platform engineers, because they're the ones that see the forest and not the trees. An individual team, just wants to get their project out the door. They don't think about, 15% average CPU utilization across 200,000 cloud servers. They don't see that opportunity in the same way that a platform engineer does. So I think that those are the sort of folks that are drawn to the ecosystem and see the opportunity first. So Wasm Cloud today in 2.0, which is in release candidate, we're getting ready to cut a 2.0 here in February, includes things like a Kubernetes operator and CRDs out of the box so that teams can just turn it on. It works with all of your pipelines, like Argo and Sift and Gripe for generating SBOMs and OCI and all of your tooling. It's compatible with Kubernetes, namespaces, with RBAC. It comes with an ingress out of the box, and it speaks open telemetry for logs, metric traces. So out of the box, it's designed to be the sort of turnkey way to adopt WebAssembly at scale.
Yeah. And it also adapts automatically via the VASI standard as well, with almost any tooling that you would need to run a enterprise scale application, right? So
Yeah,
configs, logging, as you mentioned.
it's hard. I don't want any listeners that are maybe new to WebAssembly to get overwhelmed by all of these acronyms. So WASI is a WebAssembly system interface. So think of it as a way for us to give you your default, capabilities or building blocks out of the box. So when you download your Lego Cat, CNCF Wasm Cloud, and you open up the box and you go to build your application, you're going to want to say like, hey, I need file IO, I need a blob store, I need sockets, I need messaging. Those are the building blocks that we can define with WASI. And when you think about in a normal application world, you think about POSIX as maybe my default building blocks, and then I'll bring in drivers or additional capabilities. WASI is extendable. So organizations get their kind of common building blocks, and then they can extend it with their own custom building blocks. And default building blocks that we're working on shipping are things like Postgres and Redis, and the sort of default things that we see in most applications, good abstractions for Blob Store, or even native integrations with stuff like S3. But organizations have the power to define their own messaging, and that is what we see in folks that embrace CNCF Wasmcloud and build their own platforms on it. It's very, very customizable, very extendable by default.
And not everybody might know Cosmonic yet, but behind WebAssembly, there are the big powerhouses in IT joining forces as well, right? Because it's an open source
Yeah.
CNCF project. Can you tell us a little bit more who has joined forces to make a success out of this?
Sure, sure. WebAssembly is really about is community first. And when we think about the time where WebAssembly was born, you'd have to roll back the clock, over a decade, to a world where, if we wanted to bring other applications to a browser, we might use a plugin, we might use Silverlight or Flash or even Java. And the genesis story for the project started with one of those ideas that is so bad it was brilliant. This developer who's now at Google, Alon Zakai, one day must have had an idea and said, "What would happen if I transpiled C to JavaScript?" And he did it. And we probably all remember this day. I think it was 2012. And at the top of Slashdot, or maybe you were on Reddit at the time, or Hacker News, the number one post was "Run Doom in your browser." And we all clicked on it because you're checking the news, having your cup of coffee in the morning. And this was different. We'd seen Doom in the browser maybe before, but this was like fast, and you could like grab the corner and it rescaled, and you're like, holy cow, what is this? What framework did they build this in? Because this requires like a graphics engine. And then you click on it and you saw this terrifying abomination called asm.js, and it was this transpilation library to get there. And many of us were like, wow, that looks terrifying, I'm going to go away. But luckily it planted seeds that grew deep roots. And the core browser manufacturers at the Firefox team, SpiderMonkey, at the Chrome team, at Safari, all saw this and started to think about building these optimized little paths, and then sandboxes in their browsers. And it became a way for us to have a common community standard that's free and managed by the W3C through a variety of committees to create standards for the language, much like HTML. Then for us to build foundational projects like CNCF Wasmcloud, or there's a really important engine that we use called Wasmtime that we contribute to, that then enables these commercialization strategies. And folks have choices of implementations, like a CNCF Wasmcloud or Cloudflare builds on Chrome. And you can sort of build your experience on top of that. But at this point in 2026, it's clear to say that WebAssembly has won. There's no doubt that WebAssembly is
There's not.
here, and
Is there an alternative to it? Is there
it's
anything?
not even anything close to it. If one of the projects that I'm going to release in the next a couple months is, I've been scanning the top, a couple million sites on the internet and looking for who's running WebAssembly in their browser. Just opening up the homepage, looking at the experience, and the results have been incredible. Looking at enterprise experiences like Tableau, Slack, Force, they all run WebAssembly in the browser. Looking at Adobe, all of their Express, all their apps that are listed on their homepage, all are running WebAssembly in the browser. When I log into my own bank, Capital One or JPMC Chase, they're running WebAssembly in their applications. So we have started to see WebAssembly be universally adopted across broad ranges of industry and just become part of the core infrastructure. Then what Wasm Cloud and Cosmonic are driving are, hey, we have this great tech that enables sandboxes and reuse and performance inside of browsers. Can we start to apply that on server side infrastructure? And we are seeing a definite growth across all of our channels in CNCF Wasm Cloud and in Cosmonic. And if you look out on the CNCF conference circuit, you'll see Wasm Cloud talks from organizations like American Express, organizations like Adobe and a lot of other household names that are deeply invested in this standard because they understand the advantages of building with WebAssembly.
Yeah. And if we assume that componentization and modularization of software um, is the way forward, is there another way to run to compose of orchestrate WebAssembly components other than Muslim Cloud, right? And that's also an open community thing as well. Or is that is
Yeah,
are
no,
there
look, I mean,
alternatives?
I would highlight, your company as a great example of somebody that is integrating WebAssembly into the experience and is building, a unique developer workflows and product experiences. What the team at Betty Blocks is doing, I would highlight Cosmonic, which is my company. We sort of target general platform engineering teams in the Kubernetes space with certified integrations with VMware and a new one coming for Red Hat and things like that, as well as all your cloud Kubernetes and things around there. There are even other runtimes that target like really micro devices, think like edge controllers or low power things. But the most important thing is that we're all building better together by building with WebAssembly, and it's a common standard. And this rising tide has the power to lift all boats. That's the first thing. That's we're talking about it from like the producer side. Let's talk about it from the consumer side. Like if you're a company that's watching this, you're at a bank, you're at a defense org, you're at a telco. WebAssembly has the power and unique attributes to deliver new types of experiences. And I think this is what excites me most about WebAssembly. When you think, let's go back to previous epochs of tech. The people that understood, say, cloud early and understood that it had unique properties like unlimited scaling, and were the first to sort of architect their applications around its unique properties, were huge winners in their space because they could operate a business model that was monetized differently and scaled much faster than their competitors who were still thinking about building data centers and on prem. WebAssembly has a similar power because just as the cloud disconnected scale from time, WebAssembly disconnects scale from cost. What do I mean by that? WebAssembly is so small, one of its powerful properties that you see in applications or platforms like Cloudflare or Wasmcloud or Cosmonic is you can scale to zero with zero cold starts. So organizations that think about reliability, availability, performance today, their scale, I want to run in 10 countries, I need to run in 5 cities, I need to run in East and West, is very tightly coupled to their cost. If I want to run in 10 places, well, those containers need to be on and running. WebAssembly breaks that tight coupling. So it enables business models that can scale infinitely and effortlessly and only charge users for their use. So those organizations that are very tightly coupled or bounded to consumption, WebAssembly is an ideal choice for you because it changes the unit cost economics of your products and your product lines. So this is people that I would think should be really looking very closely at this tech would be gaming companies, where if I run a thousand edge deployments, I would really my sort of COGS, cost of goods sold, is very tightly coupled to my utilization. So the ability to elastically expand instantly would be very powerful. For people in the defense org, when you're thinking about resiliency, whether it's on what you'd call a swap constrained platform, size, weight, and power, or DDIL, disconnected, delayed, intermittently latent infrastructure. WebAssembly has incredible properties for your infrastructure as well. And I think what excites me the most is, yeah, I like the standards, but what I'm most excited about is to see companies, governments, enterprises, communities embrace this tech and build new experiences that weren't possible with containers because the unit cost economics didn't work out. That is what I think excites me most about being a part of the WebAssembly community and helping to enable these new business models.
So yesterday I wrote a LinkedIn blog about the necessity for modularization or componentization of software, especially enterprise software, in this age of AI as well. And I think that that is also a very interesting topic for
Yeah.
WebAssembly and Wasmcloud. Is that in this age where AI agents will be building your software, how do you run that? Because if you have 10
Yeah.
AI agents building all of that in one code base, you have this monolithic, exponentially expanding piece of software. Where if you architect that right, you have micro components built on WebAssembly running in Wasm Cloud, and then you can really have a maintainable setup for your enterprise application, right? And you can't do that in a good way in a containerized setup. So
Yeah.
it might become increasingly important as well.
Yeah, I think you make a wonderful point, Chris. And at Cosmonic, we have open sourced a set of tooling to help people sandbox agentic workflows. We have a dedicated landing page at sandboxmcp.ai. You can also see the content and white papers over at cosmonic.com. And the core wizards and templates we've released even run on CNCF Wasmcloud. But let's talk about maybe the threat surface a little more first. Is the first thing is that we have an entity, an AI generating code that we may not necessarily trust, or has not all been audited by a human. So the idea of starting with sandboxing that out of the box is very powerful. And where we see a big opportunity is in sandboxing these agentic components for security and for risk management. The sort of core risk, as I might articulate it, is that the non-deterministic inputs and outputs of LLMs drive new risks in software as these components interact with each other. Colloquially, any idiot can trick an LLM into sending garbage to your to the next step in the agentic pipeline to drive things like remote code execution, lateral movement, prompt injection, and ultimately data exfiltration. If the LLMs are talking to software that is very tightly sandboxed, if it's a web server, it might only have the building blocks for a web server and writing out to a database or file. Even if there is a vulnerability like remote code execution, the AI doesn't have any other tooling in a container. When a container has lots of broad tooling and operating system stuff, curl, baby, sockets that I could pivot from. A WebAssembly sandbox does not have that. It just gives us only the minimal building blocks that we need. So I think that's a strong use case from both perspectives for AI. And the first being, I have AI code and I want it to run in a secure sandbox, so I know that it's scoped and permissioned correctly. And the second is sandboxing interactions between large language models and further agentic components, or even as interfaces like MCP or A2A.
Yeah. Yeah, thank you for helping us understand what Wasm Cloud is, Liam. I think there are a lot of exciting things to come, and it's not only AI that is happening, right? So this is something that is happening for some people. It might be under the surface, but it will explode on the surface in the coming years as well. A
Yeah,
good luck with releasing the version 2 of Wasm Cloud.
thank you.
And yeah, and if anybody would like to use and try out Wasm Cloud, you can just go to the website, right, and use the getting started and
Yeah,
have a go at it.
yeah. Right at wasmcloud.com. And we also operate a Slack. I know you and I chat there from time to time. And, you've got some real all star contributors into Wasm Cloud in your team, like Aditya, for example. If you just go to wasmcloud.com, right at the bottom, there is slack.wasmcloud.com. You can click there and you can join our community and chat. We'll be at KubeCon EU here in March. We'll have a booth out on the floor. So I imagine some of your listeners might be there. Come on by. We'd love to have a chat about WebAssembly, platform engineering, and Shift Down. And then personally, you can get a hold of me at liam@cosmonic.com. Feel free to drop me a note. Try to be very accessible. And I look forward to, building better together.
Excellent. Yeah. So, and for people who are not aware, KubeCon is in Amsterdam, which is almost where I am today. So we'll definitely meet up there. So I will invite everybody who watches this to come and attend that conference as well. WasmCon and KubeCon, because that is right. One is part of the other, if I'm correct.
That's right. Yeah. Well, so we actually have three events here. There is a WASM Day on Monday. I think it's Monday the 23rd in March. So there's a half day conference of dedicated WebAssembly content. Then we get into the longer pipeline of KubeCon, which is the next 3 days of content where there's WebAssembly content. And then the following weekend, there is a commercial conference called WASM.io down in Barcelona. And that is where, I think WebAssembly folks come to show off their latest tooling innovations. And I know on the top of everybody's mind will be the latest release of the standards, which we call WASI Point 3. WASI P3, and that is the sort of like the big thing that's coming to WebAssembly this year that we're all excited about.
Yeah. A lot of exciting stuff happening. Thank you for sharing all of this with us, Liam, and we'll see each other in Amsterdam then.
Absolutely. We'll see you there. Have a great day. Bye.